Another media piece from MagLab, but this time we can use a right-hand rule to see what's happening within an electric motor, a DC one in this case. Like in the previous device, this one has a current-carrying wire in a magnetic field. The battery here provides the current, just like the other one. The permanent magnet provides the magnetic field, again, just like the other one. And therefore, we have a force acting on the wire, just like the other one. The biggest difference here is that instead of moving a swing like the last device, this one is reorganized a tad and it allows a rotation. And we loop our wire back, so we effectively have two wires experiencing the force. So let's pull out our right-hand rule to consider these resulting forces. For the top wire, the thumb aligned with the current, the fingers going down with the magnetic field, and we have a force inward. For the bottom wire, again the thumb aligned with the current, the fingers down with the magnetic field, and we have a force outward. Now, this is actually perfect. The current is going in the opposite direction, and that causes forces in the opposite direction. Both forces contribute to twisting the wire loop, or rotor, in the same direction. The rotor, therefore, starts to rotate. Now, this moves along brilliantly until we reach the point where the rotor plane is horizontal. At this point, the forces are towards the middle of the rotor and therefore not contributing at all to the rotation anymore. But fortunately, we know from Newton's laws that this rotor will continue to rotate past this point due to inertia. And then past that, our forces would, well, if the current stayed the same, they would counter this movement, unless we can switch the direction of the current. Can we do that quickly at this horizontal point? Well, here's a little tricky way to do that. To switch the current direction every time we pass this horizontal plane, we use a commutator, this split ring right here. Our battery is attached to the brushes here, and they just slide along the surface of the commutator, and this allows the brushes to smoothly switch from one half to the other, and that causes the current to switch directions through our rotor. Pretty smart, right? And that's how a DC motor works. From there, of course, we can add more loops, add more wire per loops, add more commutator segments, just to make the forces stronger and more consistent. And that's the type of motor that you would run into commonly today.